Okay, we're going to talk about evaluating expressions. I want you guys to notice the word evaluating and specifically the part where it says value. That's going to help you remember what evaluating expressions mean. Remember, an expression is a math phrase as opposed to an equation where you're going to have an equal sign. So back to evaluating. Evaluating an expression means that you're finding the value of that expression when you're given the value of all the variables. So if you are given the value for variables, then all you're going to do is you're going to plug those numbers in, or another word for it is to substitute the numbers in, and then make sure you use proper order of operations to simplify. So let's do some examples. All right, one side note I want you to add is I want you to always remember to add parentheses around negative numbers when plugging in. I think that's really, really important. So highlight, star, do something to help you remember to do that, and I'm going to model it for you as well. So it tells us if x equals 3, y equals -2, and z equals -4, evaluate the following expression. So we're going to plug in or substitute in the numbers for the variables. So instead of x, we're going to put 3. The plus is in the expression. Instead of y, we're going to put -2. Now, that's kind of hard to see what's going on. That's why I say if you're dealing with a negative number, always put it in parentheses, not as a grouping symbol, but as a separator. So then minus z, again, z is negative, so I'm going to put -4 in place of z. The minus is from the expression, and then divided by y squared. Again, our y value is negative, so I'm going to put the -2 in parentheses, and then we'll square it. So now let's use order of operations to simplify this. The first thing we want to do is work inside these grouping symbols. Because there's an operation happening in those grouping symbols, the parentheses there actually is working as a grouping symbol. So we've got 3 plus -2, so that's going to give us a 1. So then I'm just going to bring everything down exactly as it's written. So now the next stage in the order of operations, or the next priority in the order of operations, is exponents and roots. We don't have any roots, but we do have some exponents. So 1 squared is 1. I'll go ahead and bring down the minus -4. And -2 squared. Notice the negative is a part of the base. It's a part of the thing that's being squared. So when you expand it out, you need to make sure that you put -2 twice. So -2 times -2 gives you a +4. Okay, so now what we have is we've got subtracting and division. So let's go ahead and do division first. So -4 divided by 4 is a -1. And let's bring down what's left. We've got 1 minus, and I'm going to go ahead and separate off that negative number. 1 minus a -1. So minus a negative always ends up turning into a plus, and 1 plus 1 is 2. And now you've evaluated that expression. Next question, if p equals 7, q equals -5, and r equals -2, evaluate the following expression. So let's go ahead and start plugging in. We've got the absolute value of p is 7, minus q, minus -5. is q. Again, make sure you put that -5 in parentheses, minus the square root of -p. So the negative right here is in the expression. Then p, let's go ahead. I guess we don't have to put it in a parentheses. You can if you want to. It's not going to mess you up, but it's up to you. And then in parentheses, it's q plus r. Q is -5 plus r is -2. So now let's continue to simplify. So we've got 2 non-traditional grouping symbols here. So I'm going to go ahead and add parentheses inside the absolute value sign, and I'm going to add parentheses inside the square root. So let's go ahead and do that leftmost grouping symbol. We've got 7 minus -5. Well, minus a negative, like we said before, is a plus. 7 plus 5 is 12, so we're going to take the absolute value of 12. Then minus is from the expression, and then let's work inside the grouping symbol. Now we actually have 2 grouping symbols in that square root, and the innermost grouping symbol is this one right here. So we're going to do a -5 plus -2. I'm going to bring down the -7 from right there, and then -5 plus -2 is -7. Now we still are working inside grouping symbols here. So -7 times -7 is 49. So square root of 49, and then the absolute value of 12. So at this point we can go ahead and say that the absolute value of 12 is 12, minus the square root of 49 is 7, and 12 minus 7 gives you 5. And we're finished. All right, next, if m equals -4, n equals -9, and p equals 2, evaluate the following expression. So m squared. So let's go ahead and put the -4 in parentheses. So -4 squared plus n, our n is -9, times p plus n. P is 2, plus is in the expression, n is -9, over negative and then p squared. Oops. Negative, and then p is 2 squared. All right, we do have another non-traditional grouping symbol here, and it's the fraction bar. So this top expression needs to be simplified fully before we divide by the denominator. So I'm going to go ahead and do the numerator kind of separately from the denominator. Within the numerator, we do have a grouping symbol, or parentheses, that is acting as a grouping symbol there. So we can say 2 plus negative 9 is negative 7. So at this point, we have negative 4 squared plus negative 9 times negative 7. So now we're going to continue working. We don't have any more grouping symbols within there, but we do have a square here, a multiplication here, and an addition there. So let's go ahead and do the square first. Negative 4 times negative 4 is positive 16 plus, and then negative 9 times negative 7 is 63, and 16 plus 63 is 79. So this is, remember, just the numerator. So let's go ahead, and I'll go ahead and say 79 over. Now let's do the denominator right here. So it's negative, and then the p is 2. So negative 2 squared. Notice the negative came from the expression. The only thing that's being squared is the 2. You could look at this like a negative 1 times 2 squared, if that helps you. So when you expand this out, you don't expand the negative with the 2. You could think of it like it's saying that you want the opposite of 2 squared. That might be a good way to think about it too. So it's the opposite, the negative, of 2 times 2, so that gives us a negative 4. So now our denominator is a negative 4, and we don't have any common factors with 79 and 4, so we are finished. And finally, if x equals 12, y equals negative 1, and z equals negative 4, evaluate the following expression. We're going to go ahead and plug in a 12 for our x minus our y is a negative 1, so we're going to plug in a negative 1. Then times our z is a negative 4, and then squared, plus y, I'm going to keep those negatives in parentheses, squared, plus, and then this one's a little tricky, then the first negative we're going to put here is in the expression. The next negative we're going to put there is because z is negative. So it's a negative, and then negative 4 squared. All right, so let's simplify from there. We do have grouping symbols here. Within that expression, we've got subtraction and multiplication. So let's go ahead and multiply first. So we'll have 12 minus, and then negative 4, or negative 1 times negative 4 is positive 4. And then we can square that. I'm going to go ahead and do that next step. So 12 minus 4 is 8. And then we're going to square 8. Now let's go ahead and write down what we have left. Okay, so now the next priority in order of operations is to deal with exponents. So let's do that. We've got 8 squared, so that's 64. We've got negative 1 squared. Notice the negative is in the parentheses, so when you expand it, you think negative 1 times negative 1, and if you multiply two negatives, you get a positive. And then plus. Now let's go ahead and work with this minus, or the negative, negative 4. Anytime you see two negatives butted right up against each other, that becomes a positive. So this is actually a 4 squared, so 4 squared is 16. And now we can add 64 plus 1 and get 65, and 65 plus 16 gives us 81. All right, I'll see you guys next time.